Good morning, everyone, and welcome to today's Autodesk Virtual Academy brought to you by KETIV Technologies. I'm here with Javier Chavez. Good morning, Jav.
Hey, good morning.
Yeah, Javier's one of our application engineers here on the team too. I'm sure that a lot of the people on this call are familiar with Javier, either from like a services standpoint, maybe even a training standpoint, to even learn things like Inventor, AutoCAD, even some simulation tools. So Jav, how's it going today?
Good. I'm ready for this. Lots of people have been asking about large assemblies for the longest time, but even more so, I think, recently. I'd say within the last year, we've had a lot of interest in classes on large assemblies. We've had just questions come in through support, so a lot of interest just in this year alone.
Yeah, and can you describe what a large assembly is, Jav? Large, I think, is a different number for most people.
Yeah, so that's interesting. I mean, there's no hard definition as to what a large assembly is. The easiest way to identify that you're working with a large assembly is the fact that it's challenging your computer. So, I've got this relatively small, lightweight laptop, and what challenges my computer might be way different than what challenges your desktop. Your desktop could be built much better, and it could easily handle, some of the assemblies that I'm going to be working with today. But again, my laptop, being as small as it is, limited in hardware, might have a tough time.
Yep. So yeah, it's not necessarily a number per se. It is, more of a performance standpoint. But it isn't uncommon that we see customers with assembly sizes of, 20,000, maybe even 30, 40, upwards of 50,000 parts within their assemblies. And so you are not alone. But sometimes we have trouble with assemblies of maybe 1,000 parts, depending on the complexity of the actual components. And with that, I'm going to go ahead and pass it on to Jav, and let's get started.
Yep. So we'll start just by talking about the agenda, the things I want to get covered today, and we'll talk about the challenges. That'll be very short, but I definitely want to touch on some things that'll improve your performance immediately. Little small changes that you have easy access to, right? That you can take advantage of immediately without an investment in hardware or even too much time. So we'll take a look at those. And then we'll take a look at some workflows that you can start implementing fairly soon as well. They do require a little bit more of a time investment. And then, the last bullet point there is maybe changing the way you design. So that's a little bit tougher, right? Because that happens at the very beginning when you're working with your part files and assemblies and sub-assemblies. It's a fundamental change in how you do things. So maybe it's something you take a look at, evaluate, and then implement, from a certain model or certain project going forward, right? But it takes a little bit more of an investment. And I think the place I really want to focus on is that third bullet point, the workflows, because I think it's something that almost anybody could start taking advantage of and see some really big gains in terms of performance, right? So with that said, right, I just want to talk about the challenges. This is how you'll know you're working with a large assembly. It's relative to you and what machine you're using. But obviously, if it's taken a long time to load, you're sitting there waiting, 5 minutes for this thing to come up and simply work with it. That's a fairly large assembly, right? If you literally see out of memory errors, again, you're probably working with a large assembly, and the immediate response is, oh, let's go get some more memory. But there's some ways to circumvent that and maybe work with the memory that you do have. Right. Same thing when it comes to poor graphics performance. Right. You can invest in a better graphics card, but again, there's ways to work around that. So if you're seeing slow sort of rotating of your model, right? It's sort of jagged and sort of discontinuous as it rotates. You're starting to see those issues, right? That most of our customers see. And then when it comes to creating drawings, it's the same thing. You start just to place your drawing, and you have to wait for a preview to open. Eventually, if you place your view, you have to wait for it to be done before you could do anything in some cases. So again, we want to make sure you're using some of these settings. Some of these settings are on by default, by the way. Some of them are not. Some of us have been modifying our application options and our settings to fine tune them, and might not realize that it's not optimized for large assemblies. So we'll take a look at quite a few of those things. I'll start by, just talking about hardware, right? This requires us to go to IT and maybe have them invest in things like what you see here. And I put these in order of what I personally like to invest in when I start looking at a machine. The first thing I start looking at is, how much memory can this machine hold, and then start speccing out the type of memory and how much memory I'm going to use, right? So what are the guidelines for, how much memory you need? It's really tough. I mean, you can use your existing machine as a guideline, as a base point. But there are some good guidelines out there. When you go to system requirements, I think you'll find that you'll see the minimal requirements, you'll see some recommended settings, and then that's it, okay? And you'll see the same thing when it comes to all these other things, the CPU, the graphics card, the hard drive, right? But again, this is how I like to sort of invest my time. I do this in this order. I look at memory first, I look at a faster hard drive, I look at the CPU, and believe it or not, the graphics last. There's a lot of really good, capable graphics cards out there now, and Inventor is using less graphics resources than ever. So it's a lot less taxing in terms of graphics resources. So with that said, right, we'll take a look at things that'll change or improve your performance immediately. So you might be using this already and not even know, right? But Express Mode has been around for a while now, and initially, it didn't have as big a gains as what we see today. 3 to 5 times faster we can load these files and open them and start accessing. And the way it works is you open up your assembly in a newer version of Inventor, and the first time you save it, as long as this feature is turned on, it'll cache the graphics information. Now, your file size will increase on your assembly. It'll increase significantly. So we'll take a peek at that here in just a moment, right? And it'll be cached in the assembly. Now, as you load other files, you edit them in place or you work on them within the assembly, so you'll lose some of that benefit of Express Mode, okay? And the easy fix to that is you can simply close the file again, open it back up in Express Mode, and you're now working with those cache versions of that information, right? And there's also a ton of settings to help you work with your large assemblies, right? So let's start taking a look at some of those, specifically Express Mode. I'll come back to application settings in just a moment, but let's go and take a look at Express Mode here for just a sec. And I'm going to go ahead and switch to Inventor. And I'm also going to turn on a timer here, right? So in this timer, I'm going to go ahead and time, basically how long it takes to open up this file. And before I do that, I'm actually going to go ahead and click open here and show you what the difference is in size. So right here, you see this skid assembly, and I'm just using a sample data set from the sample files. It's not huge, it's not gigantic, it's probably not as big as some of the data sets that you guys have out there. But it's still, if you implement these tools and practices, you should still see the same type of gains and benefits. So if I take a look at this prep skid, this has a cached Express Mode in it. It's been saved once in a newer version of Inventor. Older version of Inventor, I don't know if it came from 2014 or 2015, don't remember exactly, but you can see here, it's significantly smaller than what the later version is. So this should open up a bit faster, and we can go ahead and time it here in just a moment. So let me show you how you can access Express Mode, right? So in 2018, right, you can see here right away I can say load the full assembly or load it up in Express Mode. Okay, and so I'm going to go ahead and choose Express. I'm going to start my timer here, or maybe on the count of 3, I'll actually click open. But there we go. It's going to be 1, 2, and 3. And so I'll stop the timer here when it's finally open. But it's like 8 seconds. Okay. Now, if we open it again in full mode, I'm going to go ahead and close this. All right, we'll reset my timer. And here's another way you can access this. So if you've got this in your Home tab, we can go ahead and click on the gear, the sprocket here, open with options. It's kind of the same thing where I can open it up in full mode or Express Mode here. I've got the same type of option. So in full mode here, I'm going to go ahead and, again, get to the count of 3 here on my timer. 1, 2, and 3. right? And I'm guessing this will be like 11, 12 seconds there, right? So 8 seconds as opposed to 12 seconds, and it's even, you know, a bigger percentage increase, because really this took 9 seconds. The last one really took more like 5 seconds if you discount the 3 seconds I put in there. So significantly faster. And obviously, you know, this isn't a giant assembly, but I've seen the same type of increases in performance with the much bigger assemblies. Okay, so this feature might automatically get turned on for you, and you might not even realize it. So let's take a look at that. Now, down at the bottom left, you can see we've got 454 unique files in this assembly. That's what that number means. Okay. You can see the other number, right, shows up. If you hover over it, you get a tooltip, and it's basically total occurrences in the document. So there are 1,486 things open in this assembly, right? But a lot of them are repeated. You can see vessels are repeated. So that's what the numbers mean. And if we take a quick look now at the application options, I'll show you how this can be just turned on automatically. So if I go to application options and I focus on the assembly tab for just a moment, at the bottom, you'll see express mode settings. And it doesn't, it's enabled. So you want to make sure that that's checked so that you can start using that. If it's not, you know, you'll never see this benefit. But it automatically turns itself on assemblies that have been saved in a newer release when that count at the bottom right corner exceeds 500. So this is just at that point where it's not necessarily just going to open up and turn itself on automatically. So I'm going to go and decrease this to like 400. I've seen customers decrease this to 200 so they could see this benefit a little bit sooner with, you know, maybe some not so large assemblies. And so with that said, I'm going to go ahead and click OK. I'll close it, and, you know, simply, you know, opening this the next time will automatically have it turned on. Right? It's in express mode. So for the most part, express mode, you know, gives you access to working with almost everything you see here. You know, placing components, constraining components. This used to be a lot more limited, so it's gotten so much better in these new releases. Now, you will see certain things aren't available. So here, I don't have these simplification shrink wrap tools. If I go to, you know, change to a different level of detail, it'll probably bark at me and ask me to load the full model. And you can see there's a button up here where I can go ahead and just load the full model when I need it. Okay. And so I can toggle back and forth and do this, and you'll see, you know, it's now taking the remainder 4 or 5 seconds to load the rest of the model. And in the productivity tools, I can go back to express mode. So I can kind of toggle back here. It will ask me to save like it's doing right now and reload it in express mode. In essence, I'm really reopening this in express mode. So those are some immediate gains, benefits you can see just by, you know, using express mode. You want to make sure it's on. You want to make sure your threshold for, you know, what counts as an express mode assembly is set correctly. Okay, so that's something you can use immediately, right? Now, in application options, again, these are immediate gains you can see. You might need to change the way you work. I mean, some of these settings, if you go to application options and you go to the general tab, again, this is all in that link that I sent you. You know, some of these settings I love. I love to show command prompting at my cursor. So if I launch Inventor and it's asking me to pick a face, I like to turn this feature on. But you know what? I'll sacrifice that to work with a large assembly and get better performance. So that is the one of the first windows there that I'll turn off. Okay. The other thing that shows up on this same part of the dialog box in the general tab is the undo size. So every time you click undo inside of Inventor, it's not, you know, command by command, it's by size. If you have one operation that takes, you know, 8 megs, that might completely use up your undo capability, right, capacity. The largest you can make your undo file size is that number that you see there, 8,191. That's the largest it'll support. So I recommend setting it to that, because a undo in a large assembly you might only get one undo and that's it. You want to get more out of that. You might want to get the capacity to do, 3 or 4 undos, from a command. You're going to want to increase this value. Okay, and then optimize selection. You're going to want to put a check next to that. It'll just make it easier for you to select things when working in a large assembly. Okay, so if we move on to another tab here, okay, this is typically on by default, but on the File tab in your application options, you have a option at the very bottom that says File Open Options, and you want to make your design views associative, okay, by default. Okay, if that's unchecked, if you use a design view and you update it, change it, your drawing doesn't update and change automatically. And you'll want that because you'll want to use design views to create drawings when you're working with these large assemblies. Okay, so moving on here to taking a look at the display options, I'm actually going to go to this one and show you what some of the changes are. So view transition time, every time you change a view using some of the zoom tools or some of the view cube, it takes 2 seconds to transition over to that view, right? You're going to want to change that maybe closer to 0, so it's more immediate, right? And then the other setting you see there, minimum frame rate. On the left-hand side, you see the image, and this is something Inventor used to do really bad a while back in 2014, 2013. You would rotate your model, and it would take these parts and they would disappear for a few seconds until you stop rotating, and then it would redraw them. Okay, so it still does that, it just does it better. Okay, it just does it better. So you rotate it and you don't even notice the parts that are being redrawn because they're sort of hiding, they're not visible. It basically redraws the least visible parts. So things on the inside of that loader are getting redrawn as you rotate it, and then when you're done, they pop back up again, but they're under stuff, they're hidden behind things, so you don't even notice it. In addition, the setting went from like 10, right, to 20 hertz. So we can actually, move that back and let it draw less as we rotate, and let it redraw once we're done rotating. So it's hard to display that, hard to demonstrate that. I can't do it effectively, but those images do a good job of communicating what it does. Okay, so set it to 20, set it higher to the right, and then the view transition we'll take a look at. There's a couple other settings here for origin indicator. The less you see graphically, the less your graphics card is working. Okay, so you can take advantage of those right away. I'm going to come back to Inventor, and let's go ahead and get to our assembly. So a couple things I like to change. I like to change this right here, this highlighting. But if we go to what I was talking about just a moment ago, application options, and we go to the display tab. There we go. Here's the view transition. So let me show you how it behaves now. If I transition this way, it took about 1.5 seconds, 2 seconds, right? That's a lot harder for your graphics card to process than doing something more immediate. So ideally, I would recommend doing this, okay? Make sure your view cube matches what you call the front, the top, the back. This is going to help you with your drawings later. So I'm going to do this now, and when we get to drawings, you'll see how that works. So I'm going to change my view cube. I'm going to call this the front, and everything else is relative to that. So this is the front, up here's the top, right side, and so on. And so if I go back to this, you can see this now, okay? And let's change that setting, okay? So view transition, if I set it to 0, or at least slow it down, right? It's immediate, okay? I can get to the top, I can get to the right side, and I can rotate my view accordingly, okay? So that happens immediately as opposed to me waiting for this thing to redraw slowly with my graphics card, drawing each iteration in between front to top to right. Okay, so normally when I'm just modeling a part, I don't like that setting, but in a large assembly, I'll take it, anything to work faster. So a couple more places where you'll see this benefit. If I want to go ahead and zoom in on an object, there's a zoom to selected option here. So I pick that vessel, right? And it zooms in immediately, right? I pick another object here, or maybe I'll pick something smaller. Let's go zoom into this vessel. There we go. Immediate zoom. Okay. So, and of course, down at the bottom, you see here, I can turn off my XYZ origin indicator. It's just that much less for your graphics card to show. Okay. So I really dislike working this way with this flashing that you see here, the highlighting. So there's some other things I'll come back to turn that off. Let's get back to my list of settings here. So when you get to your drawing, right, you want to make sure that this is off. It's off by default, but some people turn it on. So make sure retrieve all model dimensions on view placement is off. Okay. Some of these other settings, we don't want to display line weights on our drawings. Okay, we know they'll plot out a certain way, a certain thickness, less for your graphics card to do. And then this one's a big deal here. Okay, it just took me a second to find it, maybe a little while ago when I was looking at this. I always forget about this, but when you go to Creative View, it wants to show you preview immediately, and it takes time to see that. Now, if we know what the top is and what the right side is and what the front is, then we don't have to see the preview. We just need a bounding box. We'll use that, right? Same thing sort of happens with sections, and we also want to enable background updates. Okay, so we'll take a look at some of those when we get to drawings, but this is a huge benefit when it comes to the drawing. So those settings you'll want to take advantage of. When it comes to the assembly, you can defer updates. Okay, update on your own initiative, right? So there'll be an update button. If something needs to update, you'll have the option to update it at your leisure, right? Enable relationship redundancy analysis. Uncheck this, right? You might want to use it every once in a while to see, hey, are my constraints redundant? And basically what it does, if you've got parts that are grounded, for example, and they're fully constrained to other objects to keep them from moving, that's too much, right? Either you fully ground them or you fully constrain them, one or the other, but it'll give you exclamation points next to your constraints, and you'll know that, yeah, there's something redundant here. There's something that's already accomplishing this mate constraint or this insert constraint that's, maybe it's a grounding setting. So disable that, turn it on when you actually want to check it, but then turn it back off. And of course, we saw our express mode settings a little bit earlier, right? So the next thing I'll focus on here is workflow, right? And we'll actually open up the assembly and start getting into this. But as an example, we use this image all the time in a lot of our slides. Okay, very high resolution image. The one on the left is that high resolution image, and then the one on the right is a lower resolution image. So what we're going to do, we want to treat it like this image. If you've ever gone to a website, it takes a while to load. Okay, chances are there's some giant image on that website that just takes a while to load. You probably don't need it. The one on the right is a lower resolution and it looks just as good. Now it'll only look, you'll only notice when you actually zoom in on it. So if I take another look at this and zoom in on it, you'll see, yes, okay, one has less detail, one image is significantly larger, and you're going to want to look at your assemblies the same way. Okay, how much detail do I need? It starts at the part level, and you decide, how much detail do I need in my parts? And it's okay to have both. You can actually have both, and have an image or an assembly that has a lot of detail, and an assembly that has a reduced amount of detail. And you can call them up when you need them and want them to make life easier for you. Okay, so this is how this works, right? We reduce detail in our assembly. So again, you see an assembly there. They both look identical, but I'm sure if you were to dig through this a little bit closer, maybe even do a cross section, you would notice some things, some details are missing. You obviously still want a bill of materials, right, that reflects the right components. You want the drawings to look correct. At this point, right, this is enough detail to communicate that with this model. Okay, So how do we do that? We're going to, start with initial modeling, right? And there's no getting around that. If you can initially model something with a little bit less detail, great. Do it early, right? But then if you start using level of details, this is one of my favorite features. You do want to know about some caveats when using it, right? But you can basically substitute that entire assembly, or maybe some of the sub-assemblies. You could substitute those to build the top assembly and reduce the part number count so that it's a little bit more manageable, right? You could also simplify some of those components, right? Or shrink wrap them. So there's a number of ways to kind of reduce that detail. And again, from a distance, you're not going to know the difference, right? Inventor will. You'll notice it when you go ahead and open up your files and work with them. So with that said, I think we'll go ahead and transition to Inventor and start working with some of these reduced details that I'm talking about, right? Leverage them in drawings, leverage them with sub-assemblies. So let's go ahead and switch over. Okay, so some more of those settings that I like to change. This is something that's on by default. Should make my graphics card work a little bit harder every time I hover over something. So I'm going to go to application options and just take care of some of those little things. Under colors, right, I'm going to disable the enhanced highlighting. I still want stuff to highlight, all right? And if you're really hardcore and you really need to save on graphics resources, you could disable highlighting. You're just not going to see a highlighted edge. So I'm not going to go that far with this. The other thing you might do is, make sure you're not displaying edges. I'm going to go ahead and maybe change my frame rate over here like I showed a little bit earlier. Okay. To do that, I'll take off maybe my 3D origin indicator just like I did before, and I'll click OK. Okay. So now as I hover over things, I only get the outlines, not the entire face highlighting, and I actually prefer that regardless. The other thing I'll do is on my View tab, I'll make sure that none of these little things that basically enhance the way we see things are interfering with my work. So textures, I don't need to see textures. That's just one more thing for my graphics card to struggle with. So I'll turn that off. Any reflections, make sure they're off. And then, I'm still seeing colored edges on the parts and things that I see here. So make sure that you're working with shaded as opposed to shaded with edges, right? This will be a little bit harder on your graphics card. Leave it as shaded, no more little edges. Okay, so now let's start working with levels of detail. And there's lots of ways to work with this. And you want to start at the lowest level assembly. Start really low, right? So I'm going to go ahead and take a smaller assembly somewhere over here. Find it. Let's go ahead and open this up. And so I like to do this. I like to open up an assembly and start to isolate it. Okay. And even within this assembly, there's several sub-assemblies, right? So I'll start with this agitator and open this up and isolate it. And you can keep going down and down and down until you get down to the lowest level. So it starts early. We're going to go to this sub-assembly and we're going to create a different way to represent this, right? Now, under level of detail, right, this is different than just turning off on and off the visibility of parts. This actually starts unloading them from memory. It makes the numbers at the bottom right go down, right? And as long as those are going down, we're unloading those from memory and hopefully using up less resources. So I'll start with this. And when I right-click on level of detail, right, I can simply create a new level of detail, manually turn stuff on and off or suppress these components. There's only 3 components in here. What I want to do is actually simplify this, okay? So I'm going to step back for a second. I didn't see any simplification tools under here. So if I look to the top, there's some simplification tools here, right? There's also some shrink wrap and shrink wrap substitute options here, very similar to what I saw just a moment ago. This goes in order. I create a simplified view, I define envelopes, and then I simplify the part. Okay, so I'm going to start simplifying this view. First thing this tool wants me to do is decide, okay, what parts are we going to start excluding, or I'm sorry, including. So I definitely want this to be part of my simplified component, this to be a part of my simplified component, and it looks like there's something here. I'll leave that out, okay? Now, right now, I can see everything, but if I choose here, view included, I could see what I'm excluding. I'm excluding some little flange here. I'm okay with that. I'm gonna simplify this, okay? So if I go to view included, right, then, or view excluded, right, I'll see the one flange that I'm excluding. Perfect. So I'll go back to view all, and what I'll do is I'll go ahead and click OK, and I now have a view representation called simple view. Okay. So I'm going to work with that, and basically anything that's excluded, like that flange, will not be part of my simplified part. Now, the next step, I want to define envelopes. So most of these parts are simple enough that I can replace them with a bounding box or a bounding cylinder. So that's what define envelopes does. And I'm going to go ahead and start with this component here. Okay. And I could replace that with a bounding box. This is the overall width, depth, and height of that object that I'm trying to replace. So here's where I choose how I want to replace it. I'm going to choose to replace it with a bounding cylinder. And the cylinder is not quite the right size. I could drag it up and down and manually put in a value, but I want it to be maybe this largest flange diameter. I'm going to go ahead and click on this button here. That'll help me snap and find the size of this diameter. So that's what I'm going to substitute it with. Okay. Now you'll notice here there is a apply and an OK button. I'm going to click apply because I'm going to continue simplifying this. It just replaced that entire component, and I missed a little bit of detail here a moment ago that I'm going to try to bring back. But now I'm going to go ahead and replace this cylinder, right? Smaller diameter. It's going to replace this pipe with a cylinder bounding box. It's the right size, except it doesn't quite meet. So I can go ahead and use this, right, to snap to this edge, or I can go ahead and bring it just so that it overlaps. I don't have to be really precise about this. It's going to be a much simpler component. Okay, so I'll click OK. All right, so it doesn't look quite right. When I did that, it took the liberty of turning off the parts I substituted. So you can see here the visibility state for simple view just got updated, and it turned off one of the components, and I think it was this one here, this agitator. So I'm going to manually turn it back on. Okay, and it's now taking up the same space. I'm bringing it back just so I can create a cylinder that represents this bottom portion of it. And I'm going to use this define envelopes tool again. And this time I'm going to pick the object again here. I don't want a cylinder that looks like this. I'm going to change this up a little bit. I'm not sure if I'm going to be able to rotate this. I was hoping I could go ahead and rotate this. So I think I'll skip that part. In the end, I'll be able to maybe model a cylinder that looks like that, but I'll go ahead and turn this off. Okay, so simplified representation of that. Now, when I'm done here, right, I can create a simplified representation of that by just clicking on this part. It will not be tied to a LOD or a level of detail. So I'm going to take an extra step here and create maybe a different way of going about it here. I can go ahead and create a shrink wrap component out of this, or shrink wrap substitute. I'm going to do a substitute. Let's go ahead and save. Okay. And I'm going to do a quick preview in the shrink wrap dialog box to see, did it get rid of anything? And it got rid of everything. So we can go ahead and tell it to show us here what's been excluded. So I'm going to go ahead and choose here, and we might be able to bring back some of this geometry this way and keep it. I'll click preview. Now this stuff stays. So in this case, I'm not going to necessarily do a shrink wrap. I'm going to cancel out of this. It doesn't work quite the same as it does with this tool, right? So it seems like it's kind of doing the same thing. I'm going to go ahead and use this. Okay. This is a substitute part. It's a whole separate part, one more part to manage. I'm going to use standard IPT template. I'm going to save it here where I need it, decide where I want to save it, and I'm going to go ahead and click OK. Okay, so there's my substitute part. I'll close it. Okay. And now in my level of detail, I'm going to create a substitute where I manually select that part that I saved out there. So I'm going to go ahead and select that part, and there it is. And so it'll be marked as a substitute. So when you're referencing it anywhere else, you'll know it. Okay. So now I have the master version, right? And it's asking me as I switch over to the master version, hey, are you sure you want to do this? And this is something all our users come by at some point. They start using level of detail and they don't know it. Okay. I'm going to say, no. Before I do that, let's go ahead and save this. I'm going to give this a name. I'm going to call it LOW. I'm going to do all caps. And this is going to be a sort of a recurring theme. I'm going to use low all over the place. And later on, I'll go ahead and activate those all at once. So with that said, there's low. I'm going to go ahead and turn that. I'm going to go ahead and save this. And I have two different representations of that assembly, the master, right? And I can go ahead and turn these envelopes back off or even delete them, right? And then I have my low representation. Of course, I got to save it before I switch out. That shows up here. So it's super simplified, and it starts at this level. So do this at every little subassembly, right? And so I'll close this. I'm done with this assembly, right? That's just this here. Now I'm going to go through and go to the next assembly, right? So here's another subassembly. I'm going to open this up, okay? And I'm going to simplify this a different way, okay? So under representations, okay, substitute level of detail, and I'll shrink wrap it, okay? So from here, right, I can simply start excluding stuff like maybe these handles. I don't need any of those. I'll just exclude them, right? I'll exclude these pins, okay? You could always go back and add them back in. From here, I'm going to go to features, and you can see here I can start removing holes, removing pockets. So if there's a opening somewhere that isn't exactly a hole, I could take those out. I can start removing fillets, chamfers. So I'm definitely going to remove all holes. Okay. I'm going to go ahead and remove all pockets. I don't really see any chamfers in here, so I'll just go ahead and remove them anyways. Some fillets are here that I actually want to keep, so I'll keep those. And then if you click Detect Features, you can see what it's affecting before you click OK. Okay. If you want to click Preview to see exactly what it's going to look like when you're done, right? It's going to be a simplified part. It's capped at the bottom. There's a lot of detail being removed there, but it still looks similar enough to the original that I can use it and recognize it. So I'll go ahead and go to the Create tab, right? And this is the new file that's going to create new location, right? New template. You can experiment with the types of solids it creates. Maybe you want to create a surface, okay? You want it to fill internal voids, remove internal parts. This will create a lightweight version of this subassembly, okay? I'm going to go ahead and click OK. And this will already be attached as a substitute level of detail on the left-hand side. Key here, I'm going to name it exactly the same as what I named that other level of detail earlier, right? It's low. I'm going to keep that throughout any of these subassemblies that I touch. So with that said, I'll save this. I'll come back, okay? And even at this level, at this assembly level, maybe I'll go ahead and create another level of detail here. I'll go to Substitute, and this time I'll choose Derive Assembly. So shrink wrap, select part file. I use that in combination with simplifying the file, and now I'm going to show you how to derive this assembly here. All right, so again, it's creating a substitute part template. I get to decide where this lives. I'll click OK. Okay, so you could start off with an existing representation, right? So if you've already got some other representation that has stuff turned off, you could start with that. You could start off with a design view that's already got stuff turned off as well. So as I go here, okay, I could decide to include or exclude components. I can go to options and start removing some of the geometry through visibility, right? So if I leave this here, if it's not visible, if it's internal, it's just at 0%, it's going to turn it off. Okay. You could remove parts by size. It says whole parts only up here just because I'm set to solids. All right, it's going to reduce this all to solids. Okay, so I'll go ahead and keep going here and come back here to the bodies. This is where I can go ahead and exclude some of these bodies, or maybe take something and simplify it. So with, for instance, the plinth here at the bottom, okay, there's some detail inside of that. It might be hollow. I can replace it with a bounding box instead. Okay. If I choose some of these, I might just be able to maybe exclude them altogether. So if you don't see your options here available, here's a trick. You go to representation and change the design view to master. And when I go back to bodies, I'll have some of these other options available, so I can simply exclude that component, right? And that was a component that was sitting here if I want to go ahead and exclude it. So with that one, you know, I'll go ahead and simplify it that way. And I would go through each one of these and start to simplify it from here on out. Okay, so this is just one of the vessels. Now I've got this substitute level of detail. If I section it through here, depending on the way I created it, most likely it'll be filled in. You're going to want to experiment with some of those options on how it creates solids or surfaces to see which one is the smallest. You can literally go to the eye properties of that file and see how big it is. So this is one 8 meg part, and you would want to compare it to the assembly that we started off with. So from here, again, I'm going to rename this level of detail to LOW. Okay, so I'll close this up, and I'm back at the top level assembly. Now here, I'm going to manually create. So this is a fourth way you can create a level of detail. You could just manually create a new level of detail, and I am in express mode. It doesn't let me work with level of details. I'm going to load the rest. Okay, so now that the rest is loaded, right, I'm going to manually create this new level of detail. Okay, and when I manually create it as opposed to a substitute, I'm basically going to, you know, some of these components, right-clicking and suppressing and unsuppressing these components manually one by one. So little things that maybe I don't need to see on the drawing level or just at a working level, I'll turn off. I'm going to rename this to low. Okay. And right now, this subassembly is loaded at its full, you know, fully detailed master level of detail representation. We're going to watch the numbers here. We're at, you know, 1486 and 454. And so here's something we can do. We can go to the Assemble tab. And on the productivity panel, there's all kinds of great tools here. If you want to explore these are like bonus tools in AutoCAD to me. But you can click here on link levels of detail. And it's going to prompt you, okay, which one do you want to link? And it's referring to the level of detail here at this top level assembly. And what this will do is, if you've done your homework and you've gone to this assembly, this assembly, this assembly, and all the other sub-assemblies and created a level of detail that's named the same, it'll link them together so that when you click on low, it activates all the other low levels of details. So I'm going to go ahead and click OK. We'll go ahead and continue there. It's just letting them know that we're about to change that. And if you look at this vessel, okay, this vessel has been replaced automatically with its low level of detail counterpart. Okay, so if I had done that with all these other assemblies, then I would be seeing that same benefit. We reduce the number a little bit here, but we could certainly repeat the process with this, right? With some of these other assemblies and create low levels of details there.
Yep, and you lost almost 200 parts there.
Yeah, just with, I only took a minute to take one subassembly and create those low level of details. If I had done that here and here and here at the platform, then I could easily lose a lot more in terms of count here. That'll open up much faster. Okay. So a caveat here with levels of detail. Okay. People will go crazy and create lots of levels of detail. Nothing wrong with that. In fact, if I close this for a second, I'm going to go and save yes, save here and say yes. Okay. When I open up that same assembly, okay, if my computer is such that it can't handle working with this large of an assembly and it runs out of memory, I can't even open it. I can select it, go to options. There's some system levels of detail that I can work with. I'm going to go ahead and load full, and the system levels of detail, the ones that exist there, every single assembly it gets, master, all parts suppressed, all components suppressed, all content center suppressed. Okay. I'm going to start with all components suppressed. I use this for diagnostic purposes, or at least, starting off with some assembly that my machine is not capable of opening. I'll click OK, click open, and any machine can do this. I'll go ahead and say yes to update. But any machine can open it with all the components suppressed. From here, you work backwards. And I want to work with the platform specifically. And so I'll just right click and unsuppress it, right? And it only loads the platform, and maybe something adjacent, vessel number 1, I'll unsuppress that. As soon as I do that, I'm no longer working with all components suppressed. It creates a new level of detail for me. And when I click save, it prompts me for that. So I'll give this a name accordingly, right? Vessel dash platform, right? And I can work this way, and the count here is significantly less, right? This is much easier to work with than the whole thing. And if this is all I need to work with, the platform interface with the vessel, then that's all I need, right? So again, you can kind of go crazy and create all kinds of levels of detail. When you reference them in a drawing, you can. You just want to be careful. If you're going to use levels of detail in a drawing, create one level of detail for every view, right? That's going to work for every view. Call it a drawing level of detail and use it in every view. You could still work with the view representations and turn off the parts that you don't need within the level of detail. So if I create a new view representation and I pick certain parts here, I'm going to change the way I select things. Right. There we go. I don't want to see this part or this part in a view. I'll turn off the visibility. I'm still working with this vessel platform level of detail. Technically, these two parts are still loaded in background, but in the drawing, I'll be minus those two parts. Okay. So I'll go ahead and save this. And I want to show you just something that'll happen within drawing. So I'm going to go ahead and create a new drawing. Okay. And as I create a base view, you notice my preview is blank. That was one of the settings that I referred to. And this is where it helps to know where the front of your assembly is. I'm still looking at this buffer prep skid that I have open in the other tab. I know I want to document the right side. Okay. I don't have to see it, but it's much, much faster because I'm not generating the preview for it. And so I can go ahead and start, scaling it up, projecting a view, out here that's isometric if I need to. I'll go ahead and move this over, but it's much faster because it's not showing me all the line work that goes with it. Okay. Over here, you can tell it to reference, a level of detail. Okay. And again, be careful and only, only work with the master or create a level of detail that's designated just for drawings. Okay, so I'm going to actually work with the master on this. And, this view 1, turns off the visibility of those other components. I'll also maybe make it associative. But in just a moment, what you'll see here as I go to create it are some green arrows here. So it should start generating the line work here in just a moment. And so I know it's faint, but right here, I've kind of frozen the screen here. There's some green corners or arrows there, and it's creating a raster image. It does this fairly quickly, and as long as you see those green arrows, it's generating a precise view and actually drawing the lines. But while you see the green arrows, it's using a raster image and redrawing this as you go, letting you come over here and create other views, section views in the meantime. Okay, so it's not a precise view, and it does it fairly quickly, right? Just so you know what's happening in the background, every time you open up a drawing, you're opening up the assembly. So I've attached a 3D mouse, and I want to show you what happens in the background with drawings and why it's so important to minimize what you're looking at with drawings and maybe only use one level of detail. So I got 2 views here. They're both using the same level of detail. And so I used a button on the 3D mice that lets me look at the edge of the paper. So this line is the edge of the paper, and it actually inserts a copy of the assembly behind the paper and projects those lines, over to the paper this way. Okay, so if view number 1 is using one level of detail and view number 2 is using another level of detail, in the background you're using more components than you probably want to. So just use one and just make it consistent through your drawings and turn off the visibility of components as you need them. Okay, so the only way you can do this in Inventor and look at the paper this way is through a 3D mouse, and there's a button that says right side view and top and so forth. So I'm going to go back to the front, and there's my paper again. Okay, so let's come back here. Okay, and we've gone through some of those options there, and I've helped quite a few people kind of dissect their assemblies. Go to the lowest level subassembly, create a low level. Go to the next level, create a low level that links all those levels. Go to the next level, create a low level that links all the levels before that. And as long as you do that, you'll have this lower level of detail that you can call up, bring up. It'll open up much faster. And then from there, if you want to maybe edit it and change it, or maybe even copy it and start to bring up other things at their master level, you can. Okay. The last thing I want to talk about in terms of large assemblies is maybe more fundamentally changing the way you design things. And we certainly don't have enough time to get into this today, but there's ways to create your models without constraints, to basically constrain them at 0 and model them a certain distance away from 0, so that when you assemble your drawings, you're not working with constraints. Every time you open up an assembly, it checks the constraints, updates the constraints to see if they still work, if parts still fit. If you simply ground things at 0 without any constraints, they open up much faster. They work much faster. The caveat there is you edit a part, change the size, it doesn't know to separate itself from another face. You have to manually go back and recreate those relationships, right? There's also a master model method that can sort of update those positions, right? These are all things we kind of teach in in one of our catalog classes on large assembly modeling. So certain things to consider. It's also inside. There's some tutorials in the help files that I referenced earlier that point to some of these types of modeling methods. So with that said, I'm going to go ahead and conclude. We showed you a few ways you guys can increase performance. Some were more immediate than others. The way I just looked at is sort of somewhere in between, where you do have to invest time, open up assemblies, create these lower level of details, and create shrink wrap substitutes or just substitutes in general. But this one would be very effective, right? Just changing your design methods. it would just require a more fundamental change in how you model things. So with that said, I'm going to go ahead and turn it over here to Nigel.
So the first one, in regards to express mode, do we lose iLogic capabilities?
Ooh, that is a good question. I haven't launched any of the iLogic commands, but I imagine it depends on the iLogic rule that you're running. So if your iLogic rule requires a function or a command that's not available in express mode, then absolutely. Honestly, I haven't tried running iLogic, so I want to say just running iLogic will work. But again, if it requires the assembly to be in full mode because of the command it's running, for example, if you created a shrink wrap iLogic tool, then you're going to have to go back to the master, or the full version, I should say.
Exactly. And you can probably leverage that using the API. Maybe do that in the background. Have to look with some of our programmers to figure out if that's even possible. When doing simplifying, do we need to simplify the models every time we open the assembly, or do they save down? And I guess Jav kind of showed that every time you create a level of detail and you switch, you have to save it. So all of those simplifies that Jav was doing were saved within the models. I noticed, I don't know if you guys noticed too when we were watching that, that assembly went from something like 3.5 megabytes to like 4.5 megabytes. So there's more data in there. All of those simplifies were kept in all of those assemblies, sub-assemblies, etc. So that's that. This question came up literally twice, back to back from different people. And I know we touched on it a little bit, Javier. What's the difference between shrink wrap and shrink wrap substitute? I know that's a question that comes up a lot.
So a great question. So you know, there's different reasons to create a shrink wrap. You might create a shrink wrap just because you want to send a copy of this assembly to an outside vendor and you want to take out proprietary data. You don't want to create it as a substitute level of detail. So when you create it that way, you can completely disconnect it from the master assembly, send it to somebody, and not worry about them having to connect back to the assembly. With the substitute, the idea is, look, every once in a while, I'm going to want to swap out the 1,000 part assembly with this one single part, and I'm going to have it as a level of detail, a substitute level of detail.
Exactly.
That's the difference.
Yep, and it comes up a lot, especially when people are using factory. I see Tav using that. That's where I first learned how to use like substitute command or the shrink wrap command for like things like those vessels, right? Those vessels were like 800, 900 parts each. If you're going to use those as factory assets, you're not going to want to have factory asset assembly. You want to make a factory asset part, which is where that shrink wrap functionality comes in a lot. Question from Mario: is it possible to shrink wrap an assembly in a positional rep? I don't know if that's one of the options. Yeah, that is one of the options. When you shrink wrap, you get to choose the visibility state or the view representation, as well as a positional rep. So yeah, you should be able to do that. Another question. We used to have problems with level of details in regards to working with Navisworks. Is this still the case? That might be a question we have to take offline. Figure out what kind of problems you're having with those levels of details.
So I can help with that a little bit. It always wants to, if I remember correctly, because it's maybe been a year and a half since I worked a little more heavily with Navisworks, but it wants to use the master. So in a case like that, what makes sense is create a shrink wrap version of that, right? And don't put the assembly in your Navisworks model.
Put the shrink
wrap part. Browse to the shrink wrap part that you produce, whether it's a substitute or not, and use that in your Navisworks model.
With that, I think that's all the questions that we have today. Like Jav mentioned, feel free to give us a call or send us an email if you have any more, maybe specific ones to your actual workflow. Again, Javier, thank you for being with us today. Yep. And again, to all of the attendees here, thank you for joining us. We'll see you next week, same time, same place. Thanks everybody for joining, and we'll see you later.
Thank you.